innovation for waste minimization.
This is a Waterborne spray gun cleaning analysis. We'll be reviewing competitive cleaning system results versus Becca cleaning system results. In the competitive systems, we'll find left behind residues causing poor atomization. This poor atomization will result in finish quality where we have poor hiding coverage, modeling, heavy film builds, color match issues, slow dry times, and contamination. The Becca cleaning systems clean all the residues, allowing for excellent atomization. Whether using competitive cleaning systems or Becca's cleaning process, the external appears very acceptable. Although the exterior of the spray guns, whether a Becca process or a competitive cleaning process, look acceptable, the inside of the spray gun may tell a different story. Let's start by looking at the air cap. Here's a close-up shot of the air cap and the air horns. As you can see in the competitive cleaning process, residues are left behind in the air horn, potentially resulting in contamination on the finish or disruption of the atomization process. In the Becca cap, the air horns are clean. The backside of the air cap shows similar results, where in the competitive cleaning system, residues are left behind on the underside of the air cap, where on the Becca process, all those residues are removed. Now let's move beyond the air cap and take a good look at the fluid tip. The fluid tip shows dramatic results in the differences between cleaning processes. As you can see, the competitive cleaning process leaves significant residues in the air distribution holes, where in the Becca cleaning process, those residues have been removed. And here's an area that has the most dramatic effect on atomization in a spray gun. It's the fluid tip. In this case, the tulip tip of an Iwata. As you can see in the serrated edges, the collection of contamination from a competitive cleaning process. In the Becca cleaning process, all the contamination is removed. With the contamination there, you are causing a disruption of the airflow, causing turbulence, which will basically affect the pre-atomization. The backside of the fluid tip shows similar results. In this case, you can see a large collection of white and red material from the competitive cleaning process. This is typical. Whites and reds are the most difficult to clean. In the Becca, you see complete removal of the residues. Now let's take a good look at the fluid needle. Precise delivery of the paint material in the spray gun is important. The needle plays an important part. As you can see, the competitive cleaning processes left behind significant residues. This could cause a disruption of that fluid delivery, causing poor results in the spray gun. The Becca cleaning process removed all the residues, allowing for precise metering of the fluid flow. Here's another shot showing the differences in the cleanliness level of the fluid needle. Let's look deeper into the fluid delivery system, looking deep into the fluid passageway. Looking deep into the needle passageway, we can take a look at, after the needle has been pulled out, the collection of residues. From the competitive cleaning process, you can see that the collection is quite significant. In the Becca process, the area is clean and free of residues. Here's a close-up shot. The results are dramatic. Let's take a look at the packing sitting in front of the trigger. Once again, we see a large accumulation of residues from the competitive cleaning process. This could be significant in the performance of a spray gun, as those residues can affect the packing seal and cause premature failure. The Becca cleaning process is clean and free of any contamination. The final part of the fluid delivery system to review is the backside, where we have the adjustment of the needle. This is an area that can be affected after several cleanings of a spray gun. As you see in the competitive cleaning process, there is a buildup and accumulation of residues. This can affect, over time, the adjustment of the needle. Another area to review is the fluid entry point. Here, where the cup attachment and or adapter attachment, a significant accumulation of residues can occur. Once again, the initial point shows a significant buildup in the competitive cleaning processes versus the Becca cleaning process. Here's a closer shot showing the results. Here we see the results when adapters are removed from the spray gun. In the competitive cleaning process, significant buildup of residues was found under the contained or contacted metal surfaces. In the Becca cleaning system, those areas were completely removed. And let's don't forget the air passageways. Here, the adjustment needles need to be clean and free in order to give proper air adjustment. As you can see here, the competitive cleaning processes once again leave residues, in this case in the air passageways. This can cause difficulty in the fine adjustment of airflow control. The Becca cleaning process, everything is clean and free for easy adjustment. So when reviewing competitive cleaning processes versus the Becca system, don't be fooled by the outside of the spray gun. The internal shows a different picture. Hopefully this will help you in making a selection of the appropriate cleaning system for your results in your operation.
Innovation for waste minimization.